Okay, so I think a fun one today would be that quantum dynamics. What is it? Infinite square well. Yeah, that's a fun one. I really like this one. I've played it a couple times in the past. If you really know what you're doing with it, then this is that square well. You can just throw in whatever you want. This becomes a lot easier once you get used to the irrational number, the Hamiltonian wave function, the capital form of the Hamiltonian with a prime feature. It's a weird thing about prime being always even or always odd, but it's not always, well, it's always odd, excuse me, but it's either in the left or right column because you might define the orientation 0, 1, or 1, 2. So when you do that, a prime number builds a pattern. It may not be the pattern like you take the series of prime numbers, you line them out, and you see if there's every two between a prime number 3, 5, 7, 11, so on and so forth. The number times itself is in a number that only represents itself by a number that is multiplied by either itself, no, not by either itself or one or something like that. I forget exactly what it is. It can't have a multiple. It's like three times or one times one is one, so one would kind of be a prime number, but it's close to the origin source, so you have a hard time. Two, most common people think of three because there's no way to multiply it together. You can't multiply one times two, so on and so forth. So that's the infinite square well. What we just talked about right there was an example of how you have to go about A1 torture testing that. So firstly, you get the right columns or the left columns, or you're starting to hello world the prime number sequence. Usually would be about some kid's accessory. You got to make sure that by the inversion of looking at it, would this become a prime number? And so you might have this really long, weird number, but does it become prime? Not only in the sense of this number times this number, but also to the motor. The engine has been primed like a weed eater, and that's how you get the compression. And if you ever try to get the weed eater going without the little gas button there, you'll understand the mathematics necessary on it and throwing out your shoulder. It'd be more practical to do the math on burning out your shoulder. So you could throw anything in here. You want to throw a y up in here, sure. Here it would be the integral of x to y, 0 to 1 in that prime feature. Because negative 1 exists or 1 exists, we could say 0, 1, or excuse me, 0, 1, 2, negative 1, 0, 1. Hamiltonian in those first order positions, I would always be next to h when you think about it mathematically. A is not going to reference 7 every time. And so that's a wave function, and you have to be able to say when that pattern recognizes here, either in this case or upside down pineapple lambda, that H is a capital form of Hamiltonian, which means the not Schrodinger here. I think it's Planck. That's Planck's constant. So that means the smallest distance or the hottest temperature, I do believe, is the two that he has. The smallest distance you can have is a Planck distance, and IH is that. It's the size of the electron to the wall. And you're throwing that into this square well, this bit of XY piece of paper that has it. Technically, the rules will work in a circle, but you're playing a linear equation game here by what is circle trigonometry, or pi. Usually, 2 pi in here, and start dealing with the trigonometry and rotation symmetry. That's what it is. You want to learn something, you got to learn rotation symmetry, because that's going to reference what a saw, a wheel, anything you want inside of there. They have smallest distances, which are each of the individual wells. So x and y on a linear equation, here in this case written out with algebraic symbols instead of the American English, which would be another variant on your multi-domain, or excuse me, multi-domains, but also sheets and PowerPoints. which is big Perkins general FM stuff. Anything you can field manual will essentially be an infinite square well. We can IH it, we can torture attack it, we can test rookies on it. And that's what's cool about science and math. I mean, you got to really kind of get into it once you start figuring out the ontologicals to it, like with Snake Eagle River, Rosetta Stone numbers, whatever it is. Here, if you're more into Curie's work, or what is it? Oh, it's just Cantor set. You know, it's about an infinitely large, well, not an infinitely large number, but an unmeasurable number, which serves a lot of functions to why you want to use algebraic symbols for something like this and teach it like a coding sequence. You know, you can apply it just to regular Windtalker code with a bunch of Marines, or you can kind of help decipher some of the webway patterns by, again, referencing some of those irrationally small distances that add up through a series of experience or evolutions. And again, in that way, you can kind of see, even if it was a racetrack for real, you're putting very specific bifurcated lines. You don't really drive the car around the track. You go left and right around the track with a bunch of differences between terms, different speeds, throttles, drifting abilities. Any of those are going to come into what happened inverted to that wave function. So again, for here, we just got the individual equation out. I could literally put out any variant of satire and or meta that may reference what it is. It's just generally a little easier to keep it in the, whatever cut coefficients or saw models you got. I don't know. But something to think about. Give it a try. Come out here and get some of this software up on your tools. You want to come over here to extensions. I don't know if it's going to let me. Let's come back down in here. And you're going to want to add that stuff into here if you want to use the geometry. If you want to take equations off of the internet, let's say you wanted to take something like this. I haven't quite got it figured out. And brute force, I can just come in here and copy this equation down and keep going. And that's going to keep me going for the most part. You probably ought to start with the beginning to really understand where that floor lives, because without catalyst material here, you're not going to have anything to do. So you're going to want to keep it in mind. You just want to hammer down that house plant. You just water and cycle on your system. That becomes the square well because of how blockchained you are to it. I'm not saying it's the most infinite of respondatory models, but if it had become such a grievance calculation, you would be able to pick up the force in that. The girlfriend doesn't like it, whatever. Just whatever. If you can theoretically say, that's an event and it may happen again because of the incident, well then, you and that girlfriend got to work it out, and you just gotta do. So here we'll see, kind of what we're looking for here. It was an IH with a sigma n. So we're saying that it's a numerological environment. Again, any house, any measurements where you say we do that commonly, they're irrational because there are so many of them, not just necessarily that they're irrational. The causal number that's going to go to this, specifically the causal to the de Broglie radius or Ingling's angle, I'm pretty sure that's an Ingling angle, or I think it's de Broglie's radius, which is basically to say not. It's not a number. We don't have a number, so C naught is going to be 0 in this case. And if you know some of this stuff about math, it's probably going to be a 0 or 1 or some form of the letter where this crosses out, where I need sunshine sigma. In this case, it has to do with the radius, the Pmax, so against any potential coronal events that it may have or solar storms, that would give us an indicator of how much potential power the sun has, and therefore you can start breaking down the other features of it. But everything's a hot drunkard walk problem in a black hole for the most part when you're feeling it out. So just something to keep in mind.